Welcome back at C Square. In this lesson we will talk about some important theorems, properties, you wanna call them, that are related to similar triangle. And the first one is, you see here, if we have parallel lines like DE, it's parallel of AC, then we have two triangles that are similar. These are the triangle BDE, the small one, and BAC. You notice I follow the corresponding parts, which is very important, right? And if the triangle are similar, you can write this proportion BD over DA is equal of BE over EC. That is the theorem. If a line is parallel to one side of the triangle and intersect the other two sides, then the other two sides are divided in the same ratio. Okay. Now, this is the converse. If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side of the triangle. So now let's take a look to this first example, where we have these two triangles, BDE and BAC. Those triangles are similar because if you notice, this is a common angle, these angles are congruent, so just by angle-angle similarity theorem we know these triangles are similar. So but now we are asked to find EC, EC being this segment you notice here. So what we're gonna do, we're gonna use the previous theorem, which says BE over EC equals BD over AD. And now let's see, do you know all this information? We'll take a look. BE, it's 9 over EC is the guy we need to find out. Let's call it X, I think it's better. Then BD is given to us, it's 6, which is good, and AD is 4. So it's a straightforward theorem, application of the previous theorem. We're going to do the cross multiplication here. 9 times 4 equals X times 6. This is 36 on the left. Of course, you can divide by 6, and that will not be a problem. Equals 6x. Divide by 6, and we end up with x equals 6. When you finish this problem, you might want to take a look and see if it makes sense. So we end up with this being 6. BE was 9. BD is 6 also. And AD is 4. I think it does make sense if you take a look to the pattern of these numbers. Let's take a look to part B. Let's see what we have here. We have M and N. So now we have this whole segment. This is 24. MR, it's 16. So that means this one is 8. 24 minus 16. We can do this math. 24 is M. And MR it's 16, you subtract them and you get 8. TV it's 9. And NV we need to find out. I'm going to call it X. So what will be the proportion? X over 9 equal 16 over 8. So again I use the previous theorem, and we have X times 8 or 8X equals 9 times 16. Of course you can multiply here, or you can divide right away, divide by 8, and then if you notice you can simplify here. 8 goes in 16 2 times, so X will be 9 times 2, 18. Remember, X is MV, the segment we need to find the length. So is that good? Does it make sense? Is a reasonable answer? And if you take a look picture, it does make sense. Very next example, we have something very similar. Two triangles that are similar, BDE and BAC, are the same reason, angle similarity theorem. So we can write proportion, or also we can use the theorem that we just discussed at the beginning. Now we have here BD, it's 12. AD is x plus 1. BE is 9. And EC is x. So what will be the proportion here? Will be, you can write in many ways, but let's say 9 over x equals 12 over x plus 1. Okay, so now we're going to do the cross multiplication. 9 times the quantity x plus 1 equal x times 12, or 12 times x. We can use distributive property here, and we have 9x plus 9 equals 12x. I think the best way here is to subtract 9x and we have here 9 equals 3x, and divide by 3. And we have x equals 3. So that is the answer for this problem. We can go back here. So this is 3 and this will be 4. Does it make sense? Is this answer reasonable? And you can take a look. It does make sense, in my opinion. Let's take a look to the next example. We have a triangle ABC, and now we know AT is 6. TC is 18. And now we know if BM is 3 times as long as AM. So if I'm going to call this guy X, and this one will be 3 times 3X, right? Is MT parallel with BC? So we need to take a look to these ratios. We're going to write AT over TC. And we need to check, I'm going to put a question mark here, if it's equal with AM over MB. So you remember, is the converse of the previous theorem. If this equality is true, then yes, the MT is going to be parallel with BC by the converse of the previous theorem. So AT is 6. TC is 18. Is that equal with AM, which I call it X, right, if you remember, and MB, which I call it 3X. If we simplify these two fractions, 6 over 18 will be 1 over 3, and X over 3X is 1 over 3. So yeah, this equality is accomplished. So now we know by the converse of the previous theorem, we know that MT is parallel, segment MT is parallel with segment BC, just because this statement here is accomplished. Okay, now let's move to a special case of proportionality, how we call it, right? We had that proportionality we used in the previous example, but now we're talking about a mixed segment, right? You notice this point D, E, and M are midpoints, right? We can see these two segments are congruent, so D is the midpoint. These two segments are congruent, so E is the midpoint, and the same for F. So we have 3 mid-segments. They're the mid-segments of the big triangle ABC. And we have a very important theorem. A mid-segment of a triangle, it's parallel to one side of the triangle, and its length is 1/2 of that side. So what we mean is right here in this picture, this mid-segment DE, it's half of AC. That's what it says here. And also DE is parallel with AC. Okay. So basically this is a special case of the previous part of the lesson we discussed. So now let's take a look to this example. In the picture below, AC is 32 and angle A is 47. Find the measure of DE. So we need to find this DE. Notice I mark this E exactly like AF and FC. Okay, why? Because we notice DE is a mid-segment. In the picture we notice BD is congruent with AD. So that means D is a midpoint. Very similar, I notice about point E is a midpoint because BE congruent to VC. We see that in the picture, so E is the midpoint. In fact, is the midpoint, not A, because it's only one. Okay, for that segment, obviously. So now what do we know? If we have these two midpoints, then DE is the mid-segment. So this is kind of a justification of what I'm gonna do now, because now DE will be half of AC. That's what the previous theorem says, that the mid-segment is half of the third side, the opposite side. So in this case, DE will be half of 32, which means DE is 16. Now let's go to the next part, which says find the measure of angle CFE, this angle here. Okay, and for this angle here, well, what do we know? This angle is 47. And if you notice, I mark them the same. Why? I can use the same process like here and prove that FE is the mid-segment. Okay, because we notice E and F are midpoints. So basically now we know FE should be parallel with AB. That is another property of mid-segments, which means angle A should be congruent with angle EFC or CFE. Let's be consistent. Why? Because these angles are corresponding angle. Let me write here corresponding angle. So this is the justification. And then these two guys have the same measure. So since angle A is 47, that is how much CFE will be, 47 degree. Okay. So in this previous problem, we used the two property of the mid-segment. Let's take a look to this example. We have also three mid-segments. We notice that because again, D is the midpoint, E is a midpoint, and F is a midpoint. So all those three segments, D, E, E, F, and DF are mid-segments. So each of these segments is half of the third side of the triangle. So let's see in the figure below, DE it's x plus 1, EF, let's do that here. EF is 2x minus 1, and DF is x minus 3. Okay, and the perimeter of triangle ABC, this is the big triangle, right, is 122. Find the value of x and the perimeter of triangle DEF. So we can start with the perimeter of triangle DEF, but I prefer to do that at the end and give you a shortcut, obviously. Okay, so now how are we gonna find x? Look at here, twice x plus 1 will be AC, this side of the triangle. Very similar. Twice 2x minus 1, the mid-segment FE, will be AB. And the last one, twice x minus 3, will be, so this is DF, twice DF will be BC. And if we add these three segments, we get the perimeter, which is 122. So this is the equation that allows you to find x just using the property of the mixed segment. The mixed segment is half of the opposite side, the third side, or in this case I said the opposite side, it's twice the mid segment. I'm going to use here distributive property 3 times, right? Okay, for x minus 2. Now here we have the last one, 2x minus 6 equals 122, and now we're going to combine the like terms, the x's first. So we have 2x, 4x, 6x, 8x, and then we have 2 positive 2 minus 2 minus 6, so that will be minus 6 equals 122. What? Two-step equation, add 6, 8x equals 128, and divide by 8 will be the last step to find x, and that will be 16. Let me double check using a calculator. 128 divide by 8, that's 16. Okay, so this is x, we found x. And now we need to find the perimeter of triangle DEF. That is the easy part, in my opinion. There is a property. The perimeter of this triangle will be half of the perimeter of triangle ABC. Okay. That is the shortcut. Of course, you can plug 16 in all those expressions you have for the mid segments and then add them. Here we have 122 divided by 2, and that will be 61. Of course, you can check this answer by, like I said, replacing x in the expression given to us, and then add those 3 numbers that represent the length of each segment. Okay, another special case of proportionality involves, like I said here, 3 parallel lines. We see that in the picture. KL, MN, and OP, we see that here are parallel lines, and cut by 2 transversal. Obviously you see them, the transversal here. This is, let's say, L and M, right? You notice we have some pieces here, these pieces, right? All these pieces here, and I'm gonna mark them different because they are not the same, follow a proportion. Let's see, Km over MO, Ln over NP, that is the statement that goes. So this is another important theorem that can be used. It's right here. If 3 or more parallel lines, so you can have more than 3, intersect two transversal, then the transversal are divided off proportionally. So let's see an example. We notice the 3 parallel lines. So now obviously we can write what? Km over MO equals Ln over NP. Okay, now you can switch this equality. That will not be a problem. Just be sure it's consistent. So now let's see what we have here. We have 10 MO is 15 equals ln is 12, and we need to find MP, which is x. So here we have 10 times x, then x equals 15 times 12. For finding x, we divide by 10. Of course, you can grab a calculator and do 15 times 12 and divide by 10. Or you can try simplifying. These are both divisible by 5. And this 2 goes in 12 6 times, so we have 3 times 6, that is 18. So NP will be 18. A last piece of advice, you want to check if the answer is reasonable. So this is 10, MO is 15, ln is 12, and this is 18. I think the picture itself and this number allows us to see that this answer is reasonable. Okay, a very similar example here, but now we have some expression, but again we're gonna have km, which is x plus 1, over mo, which is 2x minus 1, equals ln, which is 10, over np, which is 15. So again we write this proportion, and we need to find x first, and then we're gonna find ko. So cross multiplication here, and I have 15 times x plus 1 equals 10 times 2x minus 1. So we're gonna have here distributive property, 15x plus 15 equals 20x minus 10. I will subtract 15x here, and we have here 15 equals 5x minus 10, add 10, and that will be 25 equals 5x, divide by 5, and we have x equals 5. So this is x. Now we need to find how long ko is, ko being all these segments. So km is x plus 1, right? This is x plus 1. So if we plug 5 in it, that will be 6. And mo is 2x minus 1. And if we replace x with 5, we have 2 times 5, 10 minus 1 is 9. So ko will be nothing else than 6 plus 9, and that will be 15. Of course, like I said in the previous problem, you can put the numbers here. This ln is 10 and this np is 15. You can see it does make sense, the number we have for this problem. A special case of the parallel lines proportionality is when the transversal divide of the parallel lines into congruence part. You notice here, these are congruent. If that happens, then these two are congruent also. Okay, that's what this theorem says here. If OP parallel with MN parallel with KL, we see here, and Km is congruent with MO, then Ln is congruent with NP. Okay, and that is the theorem. If 3 or more parallel lines cut off congruent segments of one transversal, then they cut off congruent segments on every transversal. So let's see this problem, which is the last one in today's lesson. If Km is 3x plus 9 and MO is 8x minus 11, we need to find the value of x. So basically we see here these two guys are congruent, so my first equation will be 3x plus 9 equals 8x minus 11, and the reason is Km is congruent to MO. We can see that in the picture, so basically they have the same measure. So I'm going to subtract 3x here. And I have 9 equals 5x minus 11. I'm going to add 11. And I have 20 equals 5x, which allows me to find 5 very fast. Divide by 5, x equals 4. And now we need to find y. And of course, you may say, oh, the equation is very similar for finding y. I'm going to write 5y plus 1 equals 2y plus 10. That is correct. Well, let's justify this equation. This algebraic statement comes from this statement. Ln should be congruent with NP because we have 3 parallel lines and these transversal and these parallel lines form these 2 congruent segments, so therefore these 2 needs to be congruent also. So the previous theorem, we use it here. So I'm going to subtract 2y here. And I have 3y plus 1 equals 10. Subtract 1. 3y equals 9. Divide by 3. Y equals 3. And that's it for this problem, and this is today's lesson. Thank you. And if you enjoyed the lesson, don't forget to click the like button and come back on C-Square for more help. Thank you.